So we start, guys. This is the panel discussion. The general topic is machine learning in the context of science versus industry. Meaning, what's the difference? We'll discuss what's the difference, how to make those two like cooperate with each other, etc. So, some notes about the format, how this discussion is going to happen. I'm sorry, I'll use my phone and my notes at the same time because my phone has no recent updates in it. So it's going to be 1 hour, from which 50 minutes will be questions, both from my side and from your side. We'll be collecting questions from you too. Then last 10 minutes we'll dedicate to you meeting our guests in person. You can approach them, you can ask them questions, but make sure it happens outside, after 10 minutes are gone. Please take the front seat if you can, because it's like a discussion. It's not like a talk that you can like lay back and listen. Okay, and you can ask questions. It's preferable to ask questions in English because if you ask them in Armenian, you can still ask them in Armenian, but things may get lost in translation. I don't promise I'll catch up everything for you, although I'll do my best. But try to ask in English, because in that way all of our guests will understand directly you, not the translation. So I'll start introducing our guests. First one is Evan Shellhammer. He's a PhD to be advised by UC Berkeley as part of Berkeley Artificial Intelligence Research group with over 8 years experience in research and development spanning vision, machine learning, psychological research, apparatus and experiment automation, large-scale applications and citizen science. He's from UC Berkeley and he is the one that maintains a framework called Caffe in Python that does deep learning. On the left side from him, it's Leo Guligin from Google Cloud. He's an ML engineer from Google Cloud. He has also worked at Yandex as head of data production. He holds a master's degree in applied mathematics and physics from Moscow Institute of Physics and Technology. Next to him is Arsen Mamikonian. He's a founder and CEO of HiLearn. He holds a master's degree of engineering from MIT and has 4 years of experience in computer science with concentration on AI. Next to him is Artavast. He's the co-founder and CTO of 2Hertz with over 10 years of entrepreneurial experience, currently running 2 companies with 70 employees. He holds a master's degree in mathematics, as well as PhD in math, as well as master's degree in physics. No, in business administration. Sorry, not physics. Okay. So guys, I've introduced our panelists for today. My name is Harut. I'll be the host, fortunately or not, or I don't know. Now let's start with the audience. We'll do a quick poll on audience to see what kind of audience we have today, so that our guests also know how to answer to your questions, what terms to use and whatnot. Okay. Who of you is totally new to machine learning, have no experience, doesn't know what's that? Okay, so like 20%. And who of you runs machine learning in production? I don't say you do research, you do some, I don't know, tackling at home. 1%? No. Like 6%. How many of you use machine learning for science purposes? Even less. Like 3-4%. And how many of you use it just for fun, just learning, exploring, nothing serious? Coursera courses, I don't know. Android courses, maybe. Okay, so you know who is sitting against you, and we'll ask you questions. Okay, so I hope it will be a provocative discussion actually today, because the context of science and industry is kind of provocative because sometimes they oppose to each other. And I'll just start with the first question. Just can you tell me the basic differences of those and when the gaps are? Meaning, like, academic science in universities versus science in companies that are in the industry? What are the differences? Is there a gap between them, or you can just jump from one to another? And what are differences between like good mathematicians and good data science professionals in the company, etc.? So I guess we'll start with Evan.
Okay, sure. So hopefully everyone can hear me. If not, I can try to speak up.
I can give you the microphone actually if you want, and you can pass it over.
Thank you. So the question is really about the differences, but I want to maybe start an argument by talking about the similarities. Actually, in the course of my PhD, industry and science started to share more and more, especially in terms of the tools. It used to be the case that for papers, people would have their own code. It would just be like a mess, just on someone's website somewhere. You might not even be able to compile it, much less run it. But now there are these things like standard frameworks with unit tests and a lot of the same methodology as used in industry. And I know both industrial researchers and academic researchers and industrial engineers and startups that are all at least using the same tools. That said, they obviously have different purposes. And I think one of the main differences in my experience is just how much is open and shared, which is an obvious one, but still worth saying, right? Like as an academic researcher, I get to share everything I do. And I enjoy that a lot, because it means that other people can also take my work and extend it for different problems. Companies, often their model or their algorithm or their data is the most vital part, right? It lets them do what they do, whether it's voice recognition or it's helping map crops or what have you. There's certainly also different approaches to problems, even if they care about the same problems. Like in research, we're always looking for a novel way to do something, or new things that we can't even do yet. Where in companies, they can be much more pragmatic, and sometimes, just if you collect more data, or label it better, everything will improve. You don't need a model from a conference last week that has a bunch of bells and whistles and is fancy. You just need to kind of do every step right, where that isn't a research paper. I've done a bit of consulting in industry, and that's my experience of the same kinds of tools can work in both modes. But of course, people care about it and differs, and I'm sure the more industrial people can comment more on that.
Yeah, and we can also put some more accent on where's the line between is there a distinctive line between the data science engineers that do science or data science engineers that do engineering? For instance, there are also machine learning engineers. Where is the line between those two? I understand those have completely different focus. One is the engineer that does the technical stuff, and also, can you comment on what's the situation when the scientific people get big amounts of data that they cannot process? It's not like an example from your book that always works, how that's being handled, etc.
Sure, I can make one comment on that, and I'll hand it over. So I can speak from my experience as a student, but also in industry as a consultant and as an intern. So for instance, I've worked at Google DeepMind, and they have this very clear separation into research scientists and research engineers. And the same was true at OpenAI, which I spent some time at. Both of these are really meant for research, but they still have this separation into teams. The main difference there, as I can summarize it, just I'm only one person, these are very big organizations, is that the research scientists are mostly tasked, again, with maybe developing new workflows or new techniques and doing experiments where being able to do the experiment again isn't necessarily what's useful. It's really just we need to get some information, we need to discover something, or we need to check something. And it's the research engineering teams more have the task of, now that we can do this, or we know that this method is better than the other in certain cases, let's actually deploy it. Either scale it up or make it faster, or even just port it to another platform, because maybe the research is on certain kinds of machines, but you need to do it, say, on phones instead. I saw this for a concrete example in WaveNet, which is a way to generate speech, so they can have automatic answering systems and things like this. The original one was, I think, 10,000 times slower than the deployed one. Part of that was method. The research engineers actually came up with new ideas as well. It's not just if you're doing something new or old. It's just, again, which tools are you working with and the focus. And then as a student, you kind of just have to do all of it, right? Like if you want your experiment to work, you have to do the code. You also have to come up with the idea and do the math. You might not be as skilled at doing the full engineering side of it to make people use it, but also people cite what they can run. So as a scientist, it's also important, at least in computer science, in my opinion, to be a strong engineer, because that lets other people also carry out your science and extend it.
So they're like fully, not fully, but like highly interconnected, engineering and science. To be a good data scientist, even in the university, you need to be also good, be at least like not bad in engineering and programming and stuff.
That's my experience in AI today.
Okay. What's your comments on this, Leo? Yeah, so like I agree with all Evan just has thought, but I want to add a few moments probably. So first of all, kind of like the industry is big, and I mean from my point of view, there are like two very different types of companies. One, companies are huge and they have this effect of scale and they can actually afford themselves to like have research and actually like they can afford investing in machine learning, because like they really do care about the like predicting power of their models, because like this investment it makes sense for them. They improve the quality of their models, and I don't know, the users stay better, or kind of like, I mean, this small percentage, it's actually like you multiply it by like the size of their business, and it's a huge amount of money. And there are a lot of like much more companies in terms of like amount. There are like 100,000 of companies that actually don't have this amount of scale, and they actually can utilize much simpler models. So they actually do not need very experienced models. It just doesn't pay off. So what they probably need, they need just like more experienced engineers who have some understanding about like data science, about ML, and actually can build something based on maybe not most recent research, but like more well-established things. And actually, this is like the second aspect. What I see at least now, there is again in middle-sized companies more and more. There is no this wall again, like between the data scientists and like production engineers. The main engineer, these people, they should care about production. They should care about latency. They should actually understand some things about concurrency. They should actually like be on call. They should actually understand how the system operates. They should actually like be involved in the product development itself. And then they actually really realized, okay, we don't need to like do these kind of experiments. I mean, I can give you more specific examples. So, for example, like at my previous job, we were trying to build a recommendation engine, and like again, we started with this setup that okay, we have data scientists who build the model, and then we have like engineers who like bring it to production. It was kind of like counterproductive, because like, I mean, the data scientists, they really wanted to build a perfect model, and they came up with like, for example, very huge dictionaries for one hot encoding, like with 100,000 of like entities there. But like, I mean, the production engineers, they had like very strict requirements on latency. And the moment we kind of like merged these two teams together, I mean, the mindset changed, and people like started to understand, okay, that's actually what we care, that's actually what our users need. And that's kind of like changed everything. So these are my few points, and maybe you want to.
Yeah, I'd like to speak about now even more little guys. Like the companies I worked or teams I worked are like even smaller, like 10, 20 people. So the entire machine learning team is just like a couple of people working together, and you have to have like do everything like one person or two person. So it's very important to be able to do engineering aside doing like machine learning. And I think it's true about any kind of computer science. Like there's always a more theoretical part, and there is just engineering. But like you can't just do theory and be working in a company. You have to be able to do both.
I speak from the startups perspective. So our company is pretty small, about 20 people. Most of them are like AI engineers, but what we are actually doing, like all researchers are writing code and trying to build models simultaneously. So because of our small scale, we need to be highly focused. And I think that's the main differentiator from academia. We need to do it fast, to deliver fast, to have opportunity to survive. So I think the main difference is that our researchers are highly focused, and also we are at the same time are engineers.
Okay, so to sum it up, we come to a conclusion that, can I sum it up like, data scientists need to know, to some extent, engineering, and the more you approach to the world of study, the world of entrepreneurship, the more you need to be involved in that. Like, the more you want to go to production, you need to know that too.
I believe it depends on his career goals. So I mean, you might be a researcher for your whole life, and it's completely fine. I mean, but if you are great at it and you enjoy this, I mean, but if you want to like build products, and again, it's not black and white. I mean, some people love doing research, some people love doing products, and if you want doing products, it might be a good idea to spend some time with academia and then kind of like spend some time with industry. Because again, from my experience, kind of like, I kind of like, I started as product manager, then I was an engineer, and initially I started as engineer, it was like Windows times, whatever. But kind of like, I literally remember this, I thought I kind of like know a lot about IT, but I really remember, it was like not many years ago, how my mindset really switched after I was like half a year on call. So I mean, has been responsible for production. I kind of like was working during the nights when something went wrong, and actually I started to finally understand how it works. I mean, you can't learn it. Nowhere, because like you're not motivated like internally. You think, okay, I know this, but like when things start like not working during the night, it turns out that actually you were completely wrong about a lot of things, and because you just have never thought about it.
Yeah.
How actually it works.
Yeah, I see. So what about hiring people from universities to work for companies? Are there people that are very good at university, they have like very high grades, and do you look at the grades at all or not? But they are not fit for the companies. Are there people like that, or that's a myth or something? What's your comment on that?
Should I start? So again, like, it's not a secret, it's kind of public information. If you're asking about Google like looks at just the cultural fit, and a lot of companies are doing that. So it's just like how you behave and kind of like what are you inspired about. And like a lot of companies probably want you to be inspired, like to be a good team player and these kind of things. Again, I don't think we actually look at what you know, how you behave, kind of like what you are inspired about, whether you are a good team player and these kind of things. I actually believe it might be a good idea to join a few partnerships, or a few internships, like when you are like when you're just like at the university, or like again, if you're coming from academia and you're like telling us, like anybody who is interviewing you, not just Google, I'm contributing to Cafe, or I'm contributing to TensorFlow, or I'm contributing to any other open source. It's kind of like a great achievement, and believe me, like your chances like to get an offer are much higher. So that's my.
I'll hand it over to the industry people soon, but I'd just like to reinforce that point of many of the people I know who are involved in open source. It wasn't just something that was useful to them and others who used the code, but it's also just very informative to what you know. Because they can look at not just the code as it is at a given point, but they can see how you develop and the kinds of changes you make. So I've known people who are, for instance, very clear in like the issues they pose, or like even in their commits, they're like very disciplined in doing things step by step and like always including tests and such. And you can write that, in your CV or your resume, but I think it's very different to like have the evidence online. So in this way, for some people, if you have the time, I've seen open source can act as a portfolio of sorts. And the people I know who've been involved in open source generally have had more offers or more interviews and things, because people can make that connection in the companies that have the time to actually review materials like that, which obviously takes them more time too.
Actually, just to put it short, sorry, I finally come up with the answer. So like good grades are probably a very nice idea, but like knowledge of things, it's a better one. idea probably, and actually like a perfect GitHub and like contribution to open source, or like just your pet projects that you can share. It's probably like better things that people will look at.
Okay, so I'll actually separate the question into two parts. Like first is like what matters for like companies abroad and what matters in Armenia, because I think they're like very like people hire differently abroad and here. But for both cases, like grades matter in a sense that like you send your resume, somebody is going to screen it. Like people get a lot of resumes. Somebody might get like this huge stack of resumes. Like how does like they don't have resources to interview everyone, so they have to filter it. So one way to filter is to look at the grades. Okay, he has a very low GPA. Okay, we're not even gonna look at it. Or oh, he has open source contributions. Oh, let's see what's happening. So you have to have something that distinguishes you from the rest. Like you want to be in the smaller stack that got filtered in to get the interview. Once you get the interview, that's already completely different things. Like now people look at your knowledge. And abroad, people look at your knowledge differently. From my experience in Armenia, it's slightly different. But for both cases, you have to distinguish yourself somehow. And you can do that by having a perfect GPA, or you can do it having, like, I don't know, contribution to 2-3 projects that are very relevant to your career. If you're getting out of your university, just getting out, like it's really hard for you to distinguish. Like there are a lot of people who have good GPA. So if you don't have a good GPA, you have to contribute to open source. You have to have done a good project with one of your advisors at some point, so you can share. Like, but you have to fit whatever distinguishes you in a paper, in a page. Like that's like a link to a GitHub. Like is a very nice thing. People look at it. Like I look myself. So definitely. Like doing work, doing engineering, contributing to things that are visible to the outside person is very important.
Sorry, and one very short comment. How many of you have heard about Kaggle? So that's great, actually. So, like, I mean, my point is that, again, if you're like looking for a job maybe abroad or like in a big company, like, believe me, they all screen people who have good achievements at Kaggle. And actually, again, if you're coming to the interview and you're telling the guy, I won this competition, I mean, I'm in top 5%, like it's very high chance that people will start talking about your specific experience in this competition, and then you will probably get the offer. So it might be a good idea, and it's kind of a great learning experience for you.
So most of our engineers came from academia, and what we are looking for usually, the first thing is experience in machine learning, published papers in well-known journals, scientific journals, and if someone came with a published paper in, let's say, in science, it's a good thing to consider. And another two things, a link to GitHub, and activity and the resources that he devoted to open source projects like TensorFlow or Kaffe. So grades are not matter for us, because like for professional experience you need to be done more than just studying good universities.
Yes. Okay, so we have two more like categories of questions that we'd like to approach. Let's go over them quickly and then pass the microphone to the audience so that they can also participate. So regarding like in Armenia, for instance, there is a situation that many companies need AI extensively, and they have resources to cooperate with the universities. Like there are big companies, they can, for instance, open a department there or do some like exchange of people, I don't know what else, like organize some training courses, etc. What do you think from the industry perspective is the good way, like productive way to cooperate with the universities to have more specialists that can find work not only in science, or not having anything against it, by the way, just to help the industry too, to hire those people faster and more specialists specialists will be available for the industry? What's the steps that big companies should do, in your opinion?
Actually, we had a cooperation with Mathematical Institute in academy. So the main difficulty was setting up a real problem, a small problem, on what we should work on. And we did a small project with them. In about 4 months, we get a really nice result, which for now it's developing and will go in this release in our product. So it was really productive cooperation. But the main difficulty here is that in academia we are not used to be very time pressed. So it's one difference, and another difference is like absence of focus. Sometimes I spend a lot of time going around, making a lot of experiments, but what you need in the stage of what we are in the stage of startup, like small results in a short period of time. But I think that cooperation with academia is an essential thing for the companies to go further and to get some specialists from there.
So from my experience, like most of the people in the academia, especially people who are doing more theoretical work, have a need for data. Like, because if you have developed a model, mathematical model, you want to prove it. Like, it's mathematical model as it is. It's good for a mathematical conference, but if you want to publish in a machine learning conference, you have to prove that your model works. To do that, you need data, and a lot of times, like, publicly available data are not enough, because like a lot of people have done work on it. Like, it's a very specialized. But the data, if you can get data that's new, that nobody has published a paper on that data, you have very high chances of if you have a good model, to publish in a good conference. So that's a good way to collaborate with academia, because they want data. They want data that nobody has ever seen before. If you're a big company, you have a data set, you have a problem that you think might be solvable. Like, talking to somebody from academia might be really good, because they want the data, you want to see what's possible with the data. So if your goals are aligned, as we said before, it's like academia, it's hard to put deadlines on the academians, but if you're willing to wait, I don't know, 6 months, like up to a year, like you can get you can get big problems solved, or at least like get the answer if your problem is solvable or not. So that's one good way to collaborate with academia.
Do you have comments? Yes. Okay.
No, actually, I don't have to add something, but like, you need to support these guys who create local companies and kind of create local jobs. So that's great. And yes, I mean, have more internships, kind of like try to ask them how you can help. Okay. I think it might be a good idea, maybe to have some meetups here when you invite industry guys. It's actually what we're doing, for example, in Munich. We collaborate with the LMU, and kind of like they're coming to us, we're coming to them, and it's every summer we have a lot of interns, and that's what we are doing there. But to do so, you need like local guys who create local companies, and that's kind of your main asset.
Okay.
I'm just going to quickly list some things, and then if you're curious about how they work, you can talk to me offline. One is obviously internships, as was brought up. I know projects that can have nice splits where kind of the core research and the novelty is a paper, but of course a lot more goes into making a product. So startups sometimes will be okay with maybe publishing the core algorithm, but it still takes a lot of effort and engineering and intelligence to actually make it work. And that will be their actual product, and that will become private. And that can work very well, and I know some examples of that. Another are consortiums. So in Berkeley, some of our labs are partly funded by industry. We have joint meetups where like researchers will discuss with engineers, or we'll have talks or posters, and this is a way to help transfer things from the university into companies.
So
and also give researchers good problems, right? Because we want to do useful research too.
Okay, so if I got it right, the industry outsources some of the, let's say, tasks to university, and they do it, and then the cooperation
It's
also
like an
happens at that
exchange.
level. Yes.
It goes back and forth.
Okay.
And then the last one is that a new thing is that people are starting to also do kind of like advising or like
Uh-huh.
consulting hours.
Yes.
So this is happening in Montreal, I've heard of it. And also The House is like a startup incubator in Berkeley, where Berkeley faculty and students are just having shared offices there.
Yes.
There's like certain hours in a week where you can come and talk and have this kind of more informal exchange. You know, it's not like
Yeah,
a job. And that can help too.
Okay, thank you very much. And the last thing that I would like to touch from my side is this is more from like engineering point of view, from fully industry point of view. When you're like a good engineer, you don't know data science. What it takes to become a like machine learning engineer, what it takes to start to become a machine learning engineer. Maybe some specific courses, maybe some recommendations. What one needs to do. Specific languages, maybe like Python.
So in my own experience, I started my PhD right before deep learning became popular in vision. Right, it was in 2012, and 2012 was the conference where ImageNet, the worldwide competition, was completely won by deep learning, and a surprise to much of the community. So I actually had to learn it myself. The way I did that was actually in making Caffe, to be honest. On my own, I had been following some papers and reproducing things. Back then, there wasn't so much open source code. You just try to read the paper. But it's really one of these things that you learn it by doing it. And now that the community is more open and there are more frameworks and more projects have some kind of code, really I think understanding is one part intuition, one part like math or theory, and one part engineering and actually doing it. And I think just trying to have the cycle of come up with a project or see a project that's already done and then do it again yourself, and trying to just do as much of this as you can, starting from like small extensions and then eventually doing the entire project, is really one of the hardest but also most effective ways to do it. And you can get inspiration from the projects you see online now.
Yeah, to be more specific, what parts of math, I mean, one should go deep into to start actually understanding papers and I don't say like the most advanced papers, but maybe the ones that can really bring some value to the industry.
So one really like aggressive answer is you can start with none, right? Because this is true in a lot of computer science, right? Like many subjects have formal underpinnings like graph theory or whatnot, but it's also just knowledge of algorithms. And like this search is fast for these kinds of problems. I know I've tried it. So I think if you already have some math background, sure, start from there. And for a lot of machine learning, it's usually what's considered more fundamental math, right? Like linear algebra and beginning probability and stats. It's not like, let's do manifold calculus or something like in the first day, right? Things like stochastic gradient descent, to prove things about might be complicated, but to like intuitively understand or know the key parts of isn't so hard. But because there is open source code, and if you have more of a background as a developer, you can start more from the code. Just see what are the components, work with them yourself, and then try to map those to the math. Because there is a correspondence there. And eventually I think it's necessary to do new things, or especially to do debugging, because debugging in machine learning is often about some theoretical issues as well, or more mathematical or numerical things, like if you're losing precision, or if you have picked the wrong type of loss. That might not be obvious from the code, right? There's not going to be an exception from just your model won't work. But again, I think a more hands-on practical approach is a good place to start, because it's also usually more accessible. But really just linear algebra and intro probability will get you a long way, in my experience from talking to people who are new to machine learning. That's what's helped them the most.
I see. Thanks.
Yes, so actually, like from my personal experience again, and like experience from my colleagues, it takes kind of like 1 or 2 years, not very intensive years, but you need to have some personal time commitment to switch from engineering to machine learning. It's kind of like, it's to be honest much more difficult to switch in backwards direction. It's surprising. But I've seen a lot of examples, like people are a little bit scared, but like, again, let's be honest. I don't know. I know I'm not smart enough to join Google Brain once. You probably are. I'm not. But I'm totally perfectly okay with it, and kind of like the job of machine learning engineer in most companies, it's kind of not very difficult. You will be surprised at some point. It's more about like cleaning your data and like just like tuning hyper parameters and these kind of things, and like actually like using the frameworks that are already here. I mean, you will be surprised how rarely you actually really need to read papers. So, but answering your question, there are like a lot of beautiful courses, kind of like, especially there are public ones from Stanford, for example, on computer vision, with like even home assignments that you can just like follow. On reinforcement learning, that is like a great course from Berkeley, by the way, and there are like a lot of like just easy ones. I don't think it's a good idea to start with like mathematics. Yes, you need like linear algebra and like probability, these kind of things. Again, if you're maybe joining from like you graduated from history, maybe yes, but like if you have some technical background, at some point you will understand and realize what you need, and then you will catch up. And like two more things, kind of like very like I strongly recommend you like at some point, and the earlier the better, to start with Kaggle and like really like start doing things like try to participate in competition, because Kaggle has a great community. And so first of all, you will really start learning things by like trying to win the competition. And secondly, like there are a lot of forums and people actually share code and like discuss on the web like how they are kind of like doing that. So like you will be and actually share like nice papers, and you will be surprised like in 3 months you will understand much more, because like you finally have started doing that. And the last point, community. Community is extremely important, so it's a good idea to have like some community around the university. There is kind of like again community around Kaggle, like it's not advertising, but actually, I mean, it's a Russian-speaking community, but it's extremely nice. It's called Open Data Science Slack. You can kind of Google it. I mean, join it if you wish. So yes, that's it. Maybe.
Yeah. So let's start with what's your goal. If you want to be a machine learning engineer, like you don't need that much math, but if you want to be actually developing new algorithms, let's say reading a paper, implementing it, that's going to be tougher. For that, you need math. You need, as said before, you probably need linear algebra and probability, and the rest you'll just figure out as you go, like what you're missing. But if you're just going to like take code and like optimize it to run on production, for that you just need to understand what somebody else wrote. So depending on your problem, you might either not need anything or need a bunch. So it depends what you're working. But like slowly getting into machine learning, working with somebody who knows what they're doing, taking what they've done, making it better, like as I said before, like participating in competitions, maybe just run, like there are a lot of tutorials online, so just like pick one, like try to replicate it. Like there is a reason like a lot of people in academia, the way they start their PhDs is they're just replicating a lot of papers to become good at writing papers. So if you want to be good at doing engineering with machine learning, look at tutorials, look at what people are doing, and just replicate them. Like once you do a bunch, let's say like I don't know 5, 10 in the direction you want to do, you'll actually be able to do it some on your own. So if that's your goal, just try to do what other people have done.
So totally agree with guys. Want to add something. In some cases, when you want to really make a real difference and develop a new type of algorithms, you need a lot of deep science knowledge. In our case, what we are building towards, it's a intersection between AI, machine learning, and signal processing. So in our case, we need linear algebra, calculus, some branches of physics, and it depends like, on your goals. In our case, that was really our scientific approach.
So many categories of math that from the audience people will not apply. Don't hesitate to apply.
Correct.
Yeah. Okay, guys. From my side, I have some backup questions, but I would like the audience to participate more and ask some few questions to our host. Go ahead. Oh, he's very far. I think you can speak a bit louder, and I will repeat anyway. It will be recorded. Okay. Just turn it on and wait for 4 seconds or something. 3.
Hey guys, so thank you for great answers. I have a couple of questions. Was it me? So the first question is, we actually talked about a lot what happens when you move from academia to industry, right? What kind of qualities you should have. But what happened, like, what kind of qualities a person should have to move from another, like to the opposite direction, right? Let's say hiring people in academia, in what qualities they are looking at, like high GPA, for example, or still at the code in the GitHub, or what you are actually doing, your knowledge. And also the second question is, along with the academia as we used to know, as we know, like universities, we have a lot of research facilities like Google Brain, OpenAI, and so on. So how would you compare, like, what kind of differences they have, like in the pace, how they develop things, and so on, like that? Thank you.
Let's really go fast to the questions, because I think we'll have a lot of questions. So, yeah.
Hey, great. Yeah, so it's a great question. People do actually go in the other direction. Sometimes you might mean hiring is go back and do a PhD, be like a student, but also as universities are growing, there's more corporate sponsorship. Also, engineers are hired by universities as well. And some of these industrial labs, like OpenAI, are modeled on academic research labs. I think in general, when you want to go from industry back into academia, the best thing is, of course, if you manage to do research, it's very important. People won't judge you by your grades. People don't even judge PhD students by their grades. It's all about, like, your research. So if you publish papers, obviously that will help. But many engineers don't do that. That's not their work. It's very natural. So the ones that I've seen join academic groups are really the ones who communicate the best, because often it is this, like, cooperation between researchers and engineers, and they need to be very, like, self-directed and able to learn these things, right? Because again, some of these models you can't just, like, write down a unit test in code. It's a function of the model and the data. Like, you need to actually understand what it's doing. But I know several examples of people doing this, both at, like, OpenAI, coming in as engineers, but helping research, and even at Berkeley. In Berkeley AI Research, we have several engineers for autonomous driving, but also large systems research, and helping implement deep learning projects. And they've been picked from places like Yahoo, and even Facebook, and others. So it does exist.
So I actually made the switch at some point from industry to back to academia. I spent like 3-4 years working in the industry, then went back to do my master's. So most of people, what they look is the ability to do research. Because if you're a really good engineer, it doesn't mean if you're thrown an open-ended problem, you can come up with an answer. Because in industry, your problems are very defined, your tasks are set, you know the timeline. In academia, it's not like that. You have an open floor, like you're working with your advisor. It's like, oh, like I have this idea, let's experiment on that. And it's up to you to understand what he means, or like get that and convert it into the idea. Maybe like and the goal is to publish a paper. If you, as a person in industry, you can show you're writing blog post, you are like having a paper is very important depending on how long you've been in industry. So you have to show you can do research, and the way you show is to do papers. If you're not doing that many papers, publish blog posts with innovative ideas, like ideas that are your own, to show that you have your ideas, you have something.
So get a blog.
That's a good idea, but I wanted to also give one more example of some of the strongest researchers I know actually spend time in both. Like many people will spend a few years in industry, learn good engineering skills, also focus, which has come up many times. And so Ross Gershik is a worldwide famous researcher in computer vision and detection, but he spent, I think, 3 years as an engineer in like web technologies before going and doing his PhD. And he's not the only example of this. So one can do well to try to do both. You don't have to immediately go to academia, and if you don't choose that, you can never go back and do it. People do go back and pursue these things.
Thanks, guys. Yes. Okay, so we have a couple more questions. I guess you are first and go to the second, so please, your question.
Another set of the problems from the neural network world is the probably prediction of the time series in the neural networks, etc. I would like to know some updates on it, and particular are these popular frameworks for example, for image classification also are suitable for the time series predictions with the networks.
So I'll hand that over this way, since you work with sound, but I'll mention that all those modern frameworks I talked about, like TensorFlow and PyTorch and Caffe2 and whatnot, are perfectly good for sequential data. They work with all kinds of data, whether it's images, video, audio, text, that's fine.
One short comment. I believe we have a nice tutorial published how to build a RNN for time series prediction with TensorFlow. You can just Google for it.
So nothing to it. So you can use Caffe and TensorFlow. Both frameworks are pretty good for time series prediction. So go ahead, Google it, and you'll find.
Yeah. Next question is from the guy on the second seat, third row.
Hello. So back to the question from Harut regarding transitions between the profession, like neural professions. Like I myself came to engineering from science, and now I'm really interested in machine learning. But being big data engineer, sometimes like okay, I say let's do some home project, like read a book or do something that's, or even participate to Kaggle. But then I found that the time I spend on this doesn't really help to become a better big data engineer. But when I check new opportunities for career, I see people want data engineers to know some machine learning. And maybe is there a way to cooperate with data science team? Like because when you do something for business, you do it like you are really motivated to do it. So what is the way to approach data scientists and like try to get some of their problems and solve on your side, knowing Python, like knowing like being okay with the language and knowing some side like math, but like how to bring these problems to data engineering team and and start from that point, because just reading at home and doing some task really doesn't help from my experience.
Are there any data science at your company?
Yes, there's a data science small team, but like 4 people.
I mean, kind of like from my experience, if you come to any engineering team and ask them, okay guys, I want to help you, they will be happy to have you on board. So kind of like, I mean, you probably need to discuss with your manager, but if you will come and tell them, okay guys, I will kind of like spend my personal time helping you because I want to learn things, I don't know, everybody should be happy. So like, I mean, there are like 2 different things. I mean, sometimes the problem is that like there is no data scientist at all at company. And like I have a few colleagues like you, actually what they have done, they found just that like somebody from the business and like spoke with them and told, okay guys, let's try something. And like again, business is pretty happy to try anything about machine learning. So kind of like you can find your use case, your first use case, and again, your first use cases can be implemented in a very easy way. Like just go and do it. Like just train regression.
Let's speak offline after this panel.
Okay, thank you.
Can I have one question?
Yes, but there is one more, and then that's the last question from Armen. Please pass the mic to the guy in the center. No. Okay.
Just two questions. So, for the new startups,
I think we can have just one. Sorry, because we're time blocks. There's another presentation here, guys.
okay. So, Microsoft acquired GitHub in order. There are some rumors like to build a net that can build a net. Whether they will be able to succeed in that?
Microsoft? Come on.
Build what?
No, like in a recent news, Microsoft acquired GitHub, yes, for 7 billion.
Yes, but what part of that money concerns you more?
So GitHub is actually a large data set with lots of code that implement lots of neural networks and so on and so on. And it can be a very good data set for building an AI that can build an AI. So this is just a rumor, maybe some philosophical, yeah. Yeah, that is, and whether this would be feasible in the near future.
I mean, just like about the acquisition of GitHub.
You need to turn it on.
Yes. So kind of like, first of all, I strongly believe that Microsoft is a great company, and the public GitHub, it's publicly available. And actually, like, for example, BigQuery, I mean, we at Google Cloud, we have a publicly available dataset at BigQuery that have a lot of like publicly available code from GitHub. So like, and we kind of like use it to show you some examples, like, and you can like try to build this neural net on your own. So kind of like, it doesn't make sense to acquire like a GitHub for this type of data because it's available. And like private GitHub, again, I don't think they will violate like the law and kind of like using your private GitHub data, I mean your private source code to like train the net. Then again, kind of like the neural net, kind of like, actually what you are doing, I mean the actual bytes, it's kind of like very important, and probably you don't store it at GitHub, or at least you store it as binaries, so it also wouldn't help. Yes. But then, like, it was like about this part. So, like, first of all, I don't believe that like Microsoft acquired GitHub for any like this reason. And like whether we will be able to build a self-generating code machine, I mean, actually, like it depends what you understand. I mean, how you define this problem. Because, for example, like IntelliJ, they have a lot of plugins that actually help you to like write an efficient code. I mean that's true. And like a lot of compilers, what they're actually doing, you are writing Java code and they can compile it to byte code, and actually they're doing it pretty efficient. But kind of like, yeah. So again, it depends very strongly on the definition of your problem. I mean, I don't believe that we all as engineers, we will be replaced by AI. I mean, not at least I will retire. So kind of.
So, and if someone says that it's analytical code replacement in IntelliJ, no, it's not. It's also based on statistics, right? Best practices, etc.
Yeah, sometimes, but not exactly. So
yes.
It's kind of like it's
kind of in between. Yeah.
AI for programming is really only at its very beginning, and it's not about to happen. Just to be very serious about it. It's a fascinating subject. If you want to know more, look up program induction or program synthesis. Those are two key phrases, but it's just barely beginning. It's like fascinating, but it's not about to happen at all.
Okay, so we're confident on our lives and can go for mortgage and stuff. Okay, so one last.
We were running out of time, so.
Okay.
Because thank you very much, guys.
Thank you very much, guys. This is very productive. And to the audience, you can meet these guys. Also, they are here. You can ask your questions, approach them. Yeah, but please make it outside because there's another presentation here right now. Thank you.